and gentlemen, I am your host, Manu Mirdha, and I extend a very warm welcome to you all to the second edition of the Battery Show India 2024 by Informa Markets. Next on our agenda is a masterclass by Thermo Fisher, for which we have on stage Dr. Kyle De Silva, who is the Director Clean Energy, Thermo Fisher Scientific, United Kingdom. A huge round of applause for Dr. Kyle De Silva here, ladies and gentlemen. The topic of the masterclass is recent innovations in analytical capabilities for battery manufacturing. Abstract and discussion points would be learn about novel inline metrology and analytical instrumentation for the measurement of active material composition, coating uniformity, and defect detection in the electrode manufacturing process. Discussion points would be improve coating uniformity, measure composition inline, improve measurement of coating defects, inspect 100% of the coating thickness and width, and detect more defects. From here on, handing over the baton of the session to you, Dr. De Silva. The stage is all yours. Thank you so much.
Thank you. Audio okay? Okay. Thank you. I appreciate the very warm welcome. I'd like to, first of all, thank the Battery Show for the kind invite to come and speak to you. I also want to thank the audience for the few of you who have stayed. It means a lot. Thank you. I represent Thermo Fisher Scientific. At Thermo Fisher Scientific, we're driven by a mission. And our mission is to enable our customers to make the world healthier, cleaner, and safer. And nowhere encapsulates our mission more than the energy transition. Building batteries that can retain clean energy helps nations to achieve cleaner air, cleaner environment, and energy independence for a safer future. At Thermo Fisher, we're investing in the clean energy transition, and that starts with our investment from our organization. We're one of the world's leader in serving science, with over 120,000 colleagues globally. And we generate over $40 billion of revenue, of which we invest around $1 billion of that revenue back into new products. Approximately $100 million of revenue is reinvested in new products that serve the battery value chain each year. When I meet customers from around the battery industry, around the world, I always ask, what are the challenges that you're facing? And I get a wide range of answers. Customers are driven by achieving quality. Quality to reduce scrap, quality to improve the safety of batteries. It's the number one reason that we hear as we speak to customers. And how are they trying to do that? They're looking for novel technologies that can improve their understanding of their materials and their processes. So Thermo Fisher believe that we have a role to play in solving this challenge. And we're doing it through three main activities. Sorry, I'm competing. We're doing it through three main pillars. Firstly, we're investing. We're investing in our talent. So we're bringing battery experts into Thermo Fisher so that we can help to develop the products of the future. Just in the last 6 months, we've acquired talent from a range of tier one battery companies. 2 of them are in the room here with me. You can raise your hands, thank you. Why are we bringing in this talent? Because we believe that we're going to create the next generation of battery products to help improve quality and safety in your products. Next, we're improving customer experience. Last year, we opened, in December last year, it's coming up to our anniversary, our Battery Center of Excellence and Customer Experience in Seoul, Korea. I'll share a few words on that on the next slide, but it's a phenomenal facility where people can collaborate from across the world, test new products, understand the characterization of their materials, and come and see and be trained on these technologies. Finally, we're investing in innovation, brand new products for the battery production environment. So this is our new Battery Center of Excellence in Korea. There's a great video online. I encourage anybody to take a look. It's a massive investment, over $5 million. What we have there is experts in application service support. You can bring your samples, you can try out the machinery, you can create test reports. We have laboratories. We also have a roll-to-roll simulated production line to test all of the metrology capabilities that we have at Thermo Fisher. I mentioned we're investing in new technologies, but we have a broad portfolio already. Thermo Fisher serves the entire battery chain from the mine to the production line. But today I'm going to be focusing on a narrow area of that capability. But if you have interest in any of the other technologies on the screen, please visit the booth, speak to our specialists. We'll be happy to talk to you. So the three technologies I want to speak to today is firstly extrusion, a rapid and accelerated mixing technology for people developing new battery materials or working with battery materials in a pilot line environment. Secondly is composition control. Here we have new Thermo Scientific Markmetrics all-in-one process Raman analyzer. What does this give you? Very precise composition measurements of your material as it moves through the battery process. Finally, I'm going to be talking to you about a novel technique called mass profilometry. This is a new tool in our product called the Thermo Scientific Linspector Edge Mass Profilometer. This tool gives you added confidence that your material is within spec by measuring 100% of the material all of the time in your coating line. So this is our new Energy 11. It launched around 10 months ago. It's a very small format mixing technology. It fits on a benchtop. It fits in a fume hood, but has the capabilities of mixing up to around 200 liters equivalent. It's a continuous process mixing capability with very high shear forces. It's designed to be adaptable and work in glove box environments so that you can create mixes and compositions very quickly and with very high dispersion. So why use extrusion? Well, extrusion gives continuous capabilities in your mixing process. So you don't have as many batch-to-batch variations. You get greater dispersion of the material, fewer agglomerates and aggregates of your particles. So consequently, you have a very fine mixing process. You can also mix powders as well as slurries in the same system. It also allows you to save on time and labor. The mixing process is much quicker due to its very high shear forces than an equivalent technology such as orbital or planetary mixing. So it allows you to save time. If you consider using extrusion versus conventional mixing with wet or dry coat, you can cut out several steps of the mixing process. So this allows you to save significant time. It improves the quality of your process and reduces the wastage of material. Our second new innovation was a product that we launched last year, the Thermo Scientific Markmetrics all-in-one process Raman analyzer system. This is a very small system. It's about the size of an encyclopedia, actually around this size. And that's why we call it the all-in-one. It consists of up to 4 probes. There's one probe on the screen. The probes can be placed anywhere in your process, and the data is sent back to the data handling station. What does it give you? Inline, continuous monitoring of the composition of the sample. It doesn't require any sampling. It doesn't contaminate the sample, and it's non-destructive. So it allows you to continuously monitor with high degrees of confidence. It generates Raman spectra that give a unique fingerprint to each material or each mixture of materials. We can measure the fingerprints to calculate the concentration of each sample. So we know process engineers do not like to look at complex spectra. That's why the system is designed for continuous process environments. You could simply measure the components, and the components change from hour to hour, minute to minute, day to day. So very accurately, very precisely, very simply. So it allows you to have good confidence in the control of your slurries and powdered material. The final product that I want to share with you today is our thermoscientific Linspector Edge mass profilometer. So this is designed for electrode coating processes, and it's designed to measure the coated patch from edge to edge. This is really unique in the industry. It allows you to measure and detect defects by recording data on 100% of the material continuously. It also allows rapid feedback of those data to an automatic process control tool so that you can adjust your process on the fly to reduce waste, eliminate defects, and reduce scrap. So if you take a look on the picture on the left-hand side of the screen, it shows a conventional scanning gauge. Many customers, many companies are exhibiting these gauges this week at the battery show. This is how batteries have been produced for the last 20 years. You simply measure the thickness of the gauge by moving, of the material, by moving the sensor back and forth across the coated material in a single zigzag line. The challenge here is the line covers around 2% of the material. 98% of the material goes uninspected. You have no idea if there's a thick patch, a thin patch, a defect. So with our new system for the mass profilometer, we use an X-ray based source and measure across the entire width of the system and detect using a complex array of sensors. This allows us to measure the material moving at fast speeds, up to 100 meters per minute, and measure 100% of the coated material. It facilitates you seeing defects that you wouldn't be able to detect through other processes. You can take a look at the edges of patches. You can look at bleed of the active material at the edges. You can look at what's called bunny ears, thick patches at the edge of the material. Ripples, voids, scratches, defects can all be detected using this novel technology. So this is how the data is represented. You can see in the machine direction on the right-hand side, you can see the thickness and basis weight of all of the coated material. On the left-hand side, you can see the heat map. Really, you could see down to the millimeter resolution of any thick or thin patches on the left-hand side through the material. You can automatically archive the data, and you can also create flags and alarms if any of the material is out of specification. So here you can see on the left-hand side a very high definition visual image of a coated patch. And you can see some dark patches, some light patches, but you can't tell whether the material there is thick or thin. And the important part about electrode coating is it's a little bit like Goldilocks' porridge. Too thin is not adequate. Too thick is dangerous. It has to be coated just right to remove the possibilities of failures of the battery at a later stage. So here we can see some areas of dark patches. We don't know if they're thick or thin. On the right-hand side, we can see some patches that the machine has detected that are thick. They're out of specification. But draw your attention to the long strip on the right-hand side. The long strip, the long strip is unfortunately a large area of thick material out of specification that you could never detect through visual inspection. So it shows that it's a complementary technique to existing visual inspection, but it goes one step further to give you extra confidence. So here you can really see quite high definition of very, very small defects, high loading and low loading or scratches. And you can see that we get great resolution at the edges of the patches. So here's an example of a real patch battery where you can see that there are some ripples and there are some coating defects. The idea is that you can make adjustments on the fly. Once you find a strip that is out of tolerance, such as the one on the left-hand side, you can adjust the flow parameters of your slot die during the process to reduce the number of defects or non-compliances. Here's an example of flakes, material that is broken off and it's dropped back onto the electrode. Here you can see very small flakes down to less than a millimeter, and the machine can detect this at, again, 100 meters per minute. Very easily, this is cathode active material on top of cathode active material. Small flakes, very difficult to see. So thank you for your attention. Hopefully I've been able to share with you that Thermo Fisher is investing in innovative solutions to help support the drive for greater quality in battery materials and help give you greater insight into your product quality. We're a global company. We serve over 100 territories and we're able to support you both in India and beyond. So I'd like to thank you for your attention, but before I finish, I just want to add one more thing. A little like Steve Jobs, he always had one more thing at every Apple phone announcement. We have a really great series of webinars coming up. We're really proud of this. They launched this week. It's an 8-week series. It's starting with 2 key opinion leader panel shows where we're having interviews with real battery experts in the field. So on the left-hand side is our first panel on the 14th of October. We have Sir Stanley Whittingham. For those of you who don't know, Stanley received a Nobel Prize for his development of rechargeable batteries. He was recently knighted in July by the King in UK. He's one of the most renowned energy scientists around. So Stan is joining us together with Dr. Lewis Piper, who leads the Warwick Manufacturing Group. Lewis has collaborations with many Indian companies, including Jaguar Land Rover, Agratas, and so on. And we also have Ines Miller, who's joining us from P3, a phenomenal battery consultancy who are able to support new companies in their battery development. So that's our first event. Our second event is starting at the end of December. And we have 3 KOLs in developing next generation batteries. Yuri Gagostil from the Nanomaterials Institute, Shirley Meng from the University of Chicago, and Kang Zhu from SES Technologies there. So a phenomenal event. Please register, sign up. We'd love to welcome you all there. So with that, I'd like to thank you for staying around and your attention. Thank you.
Thank you so much, Dr. De Silva. I would request you to please be here with me for 2 more minutes. You've imparted so much knowledge to us with this lovely, insightful, educative, and informative masterclass that I've just witnessed. I would like to present a memento to you as a token of our appreciation for being here with us today.